This is area and perimeter and all kinds of scaling. It's a review for a geometry test, but perimeter area scaling of geometric figures. Use trigonometry, find the perimeter area of a regular polygon. Remember, this is going to be 1/2 times the apothem, which is that. It's the distance from the center perpendicular to one of the bases times perimeter. So I have to find the perimeter. So I need to find the side. Well, this is 1, 2, 3, 4, 5. So let me see how big each central angle is. 360 divided by 5 equals 5 times 7 is 3510, 72 degrees. That means each one of these is 36 degrees. This is 36 degrees. I'm supposed to use trigonometry. So I know this is 9. How do I find this? Well, what do I have? I have the adjacent and opposite. So tangent of 36 degrees equals adjacent, which is 9, over, opposite, not adjacent over opposite, opposite over adjacent. Did I say adjacent over opposite? Opposite over adjacent, 9. So 9 tangent, I multiply both sides, 9, x equals 9 tangent 36. Well, that's this. So the whole side is 18 tangent 36 degrees. And I've got 5 of them. So 5 times 8 is 40. 5 times 5, 6, 7, 8, 9. So this is 90 times tangent 36 degrees. That's the perimeter. And then the area will be 1/2 9 times 90, which is 1/2 9 times 45. Not 1/2. 1/2 9 times 90, which is 9 times 45. 1/2 of 90 is 45. So what is 9 times 45? 405. 405 tangent 36 degrees. You could also write it's 9 times 90 divided by 2 tangent 36. But this is simplified. 90 divided by 2 is 45. 9 times 45 is 405. I've got it. All right, next one. This is an octagon. 1, 2, 3, 4, 5, 6, 7, 8. So the central angle is going to be 360 divided by 8, which is 8 times 4 is 32, 45. 45, so each one of these is 27.5. And now I need to find this, and I also need to find the apothem. So let me check on this. I know I have the hypotenuse, so I have to find the sine. Sine of 27.5 degrees equals opposite, I'll call that x, over 8. So 8 times sine 27.5 is half of that, so the whole thing is 16 times sine 27.5, but there's 8 of them. So what is 8 times 16? 128 sine 127.5. 128 sine 120, not 127, 27.5 degrees. Okay. $16. Wait a minute, wait just a minute. 8 times sine of 27.5. So 16. And why did I do, wait a minute. Why did I do 4 times 16? I did 16. Did I do 16 times 8? Yeah. So this is 128 sine 27.5 degree. Okay, how do I find the apothem? Well, I need the adjacent, so I'm going to go cosine of 27.5 degrees equals the adjacent, which is the apothem. I'll just put apothem. divided by hypotenuse, 8. So 8 cosine 27.5, I multiply both sides by 8, is the apothem. So the area is 8 cosine 27.5 degrees times 128 sine, which is the perimeter, 27.5 degrees. And then I have to divide that by 2, so I'll just divide this by 2. So I'll say 4 cosine 27.5 times 128 sine 27.5 degrees. That would be the area. So remember, area is 1/2 apothem times perimeter. All right, let's try this one. Find the length of the arc and the area of the sector. Well, if the arc degree is 80, so is the central angle. And the length of the arc would be the central angle divided by 360 times the circumference. So central angle is 80 divided by 360 times the circumference, which is 2 pi r, which is 18 pi. And let me see. 18 goes in 18 once, 18 goes into 36 twice, 8 divided by 2 is 4, so this is 4 pi. Area of sector, well, it's going to be the same ratio. It's going to be 80 over 360, 80 over 360 times pi r squared. Well, it's 81 pi. That's the area of the whole circle, pi r squared. So let's see. 9 goes into 81 9 times, 9 goes into 36 4 times. I got rid of the zeros. What's 8 over 4 is 2. 2 times 9 is 18. 18 pi. Let me double check that. I've got to double check that. 80 divided by 360. Well, you know what I'm going to do? No, I'm going to do it like this. 80 divided by 360 times 81 pi. And this would have been 2 times 9 is 18 pi. 80 over 36 times 18 pi. The zeros go away. That's 1, 2. 8 over 2 is 4. That's 4 pi. Area of sector. Well, I'm going to do it. Let me see. I've uploaded this already. Let's see if it gets it right. What number is this? Number 12. Number 12. I'm going to check it and at the same time check Gemini to see if it got it right. Let's see. Number 12. Let's see if it even has the right problem here. These formulas for parts. Yeah. Blip, blip, beep, boop, boom, boop, boop, boom. Oh, it made a video and everything. 4 pi. Yeah, there it is. 4 pi. Let's see the area of the sector. 18 pi. Yeah, there you go. Oh, I forgot the units. So Gemini got it right. Okay. Let me do the next one. Length of arc. It's the central angle is 90, so it's 90 over 360, which equals 1/4, times, and then it's going to be 2 times the circumference, 2 pi r, so 12 pi. 12 divided by 4 is 3, so 3 pi is the length of the arc. And then the area of the sector will be 1/4, the portion of the circle, based on the central angle, times the area. Area is pi r squared, 36 pi. 36 divided by 4 is 9. So this is 9 pi. All right, there's that one. Find the area of the segment, shaded region. I think it wants that. That's all I can think. There's no shading here. But anyway, so I need to find the area of the sector, and then I have to find the area of the triangle and subtract them. Well, how am I going to find that? If this is 120, that's 120, and then this little angle on that side is 60, that's 30, this is 90. So now I know side opposite 90 is 2x, side opposite 30 is x, so that's 6. The height of the triangle is 6. And the side opposite 60 is x square root of 3, so it's 6 square root of 3 is this. So the whole base of the triangle is 12 square root of 3, twice that, and I multiply that by the height, which is 6, and I divide it by 2. So that's going to be 36 square root of 3. That is the area of the triangle that I will subtract from the area of the sector. How do I find the area of the sector? Well, it's 120 divided by 360, which is 1/3, times pi r squared. The r is 12, so times 144 pi. So 144 pi over 3 minus 36 square root of 3. Let me double check this again. 120 divided by 360 is 1 over 3 times 12 squared is 144 pi. Yeah, that's it. So it's 144 pi over 3 minus 36 square root of 3. Okay, number 15. This is a 60-degree angle. That means that's a 60-degree angle. And so again, I think they want that. I'm going to do the area of the sector. And the sector is 60 over 360, part over whole, equals 6 over 36, or 1/6 times. What's the area of a sector? Pi r squared times 64 pi. What is 64 divided by 6? I'll divide by 2 equals 32 pi over 3. So that's the area of the whole thing is 32 pi over 3. I want to subtract from that the area of the triangle. Well, if this is 60, this whole thing is 60, that's 30. That's 30. This is 60. This is 60. So I know the side opposite 90 is 2x. The side opposite 30 is x. The side opposite 60 is x square root of 3. So what's the area of that triangle? The base is 8. The height is 4 square root of 3 and 1/2. So 4 times 4 square root of 3 is 16 square root of 3. So the area of just this part is going to be the whole thing, 32 pi over 3 minus 16 square root of 3. And I'll just put it in, I guess it's square units because they don't give units. I'm going to put that into Desmos, and I will put 32 pi over 3, minus 16 square root 3, 5.797, whatever, however many digits they want you to do it. So, all right, the diagonals of a rhombus are multiplied by 2/3. What are the effects of the perimeter? Well, perimeter is linear, so it would be times 2/3. Area is squared, so it will be times 4/9. That doesn't mean x, that means times. Times 2/3 times 4/9. Describe the effect on an area, so that's a squared thing. Area is the linear squared, whose circumference has been doubled. Circumference is a linear measure, so if it's times 2, the area equals times 4. All right, so that's that whole sheet. Trigonometry for all this stuff and whatever else we had to do there.